All right, so this is the third conversion we did. We were converting the binary values into octal and hexadecimal values. And we did some questions as well, as I remember. All right, yeah, so these are the questions we went through. And today, we are going to start the next conversion. Oh my God. Something is happening with my whiteboard. Hold on, people. Okay. So let's do this. And today's conversion . Yeah, converting octal and hexadecimal values into binary. Now, this is very easy if you can remember what we have done in the previous conversion, right? In early conversion, the binary value was given and we divided into 3 bit groups. So we consider one particular group as a small binary value, and we took the decimal equivalent for that small binary group, right? Like we did over here. Right now, today, from here, what we are going to do is we are going to take a one symbol of the octal value. Let's first take octal value. And that symbol is going to represent as a 3-bit value, right? So as an example, let's take this as an example. So let's say convert 437 octal into binary equivalent. Right. So in converting the 437, the octal value into binary, it goes like this: 437. Now it will be written as 3-bit values. Why we are taking 3-bit values? Because the 8 is equal to 2 to the power 3. Right? So each and every symbol of the octal value is taken as a 3-bit value. And it's very easy to find the values of these 3 bits because we know the place values. The place values are going to be 1, 2, and 4. So these place values are always 1, 2, and 4. So now what are we going to do is we are going to fill these small squares in a single group using these values. And we are going to find this particular value. Right? So if you are going to represent 7, you need 4, you need 2, you need 1, because 4 plus 2 is 6, 6 plus 1 is 7. So it should be 1, 1, and 1. To represent 3, you need a 2 and a 1. That means 1 and 1 can be put over here, but nothing's from the positional value 4. And when you are going to find 4, you can easily find it only using the 4, no 2s and no 1s. So that means 1 over here, 0s in these points. Right? So now we can write the value or the particular answer that we are referring to using 1, 0, 0, 0, 1, 1, and 1, 1, 1. So this is going to be the binary equivalent. People, is that clear?
Yes, sir.
Right, great. Okay, let's write this down. This is example number 1. Then I'll go to the example number 2. In case if you are not getting this, please let me know, right? I will go through this again. Hey, Sarah, I think you have entered the room just now. We were discussing the last conversion, so it's better you write this down. Later, you can see how the conversion is done when I'm explaining the hexadecimal part. Right, so write it down quickly. And people, give me a minute. I have to give medicine to my little one. So you copy this and let me know. Yeah, Udan, yes, Udan, like if you are like thinking about 3 to 7, so 3 can be written as 0, 1, 1. No? So like the leading 0 can be ignored, right? It doesn't matter. It doesn't matter. Okay, so yeah, so 1 is done. How about others? Anyone who is still writing? Okay, right. All right, someone has just come into the room. Yeah, we were discussing about the conversion of octal and hexadecimal into the binary. So like, I'll give you 2 to 3 minutes. Please write this down as quickly as possible. So then I can move to the next one.
Dance.
Right. Latecomers, are you done? Anyone who is still writing? Okay, so I'm moving forward. So the second example, let's take it like this. Example number 2, let's say convert (4BF) 16 bits into its binary equivalent. Right. So the hexadecimal, the 16, since it is the base of the hexadecimals, so 16 equals to the power 4. So what we have to do is we take the value 4BF, the hexadecimal value, and now we are going to write each and every symbol as a 4-bit value. Each and every symbol as a 4-bit value. And as we discussed earlier, the place values are going to be 1, 2, 4, and 8 for these places. So 1, 2, 4, and 8. So each and every group is going to have the place values of 1, 2, 4, and 8. And how we are going to fill these things? Now, you should be very careful because there are English letters. So you have to remember what are the English letters, or like what's the representation of the English letter. So F represents 15, right? So F is representing 15 and B is representing 11. So 15, we need 8, we need 4, we need 2, and we need 1. Those 4 all together will perform 15. So it goes like this. And 11, to find 11, we need 8, we need a 2, and we need a 1. So nothing above of 4. So like there will be 1 over here, 1 over here, and 1 over here, which will create 11. And this does not contain any value. That means it's going to be the 0. To create 4, we need only this. That means 1 over here and zeros in every other position. So that gives us the conclusion. From here, you are going to have 0, 1, 0, 0. From here, you are going to have 1, 0, 1, 1. And from here, you are going to have 1, 1, 1, and 1. And since the leading 0 does not have a proper value, we can ignore that. Right? We can ignore it. And then we can write the final solution as 1, 0, 0, 1, 0, 6 ones in binary. Yeah, Sanetma, yes. Sanetma, this is the previous one. Is that okay? Right. So people, go with the second example. Is that clear, everyone? All right. So copy it down. Let me know when you are done.
Done, sir.
All right. Anyone who is still writing? Okay, so Rizwan, we have a birthday boy in the room. Happy birthday, Rizwan.
Thank you, sir.
Right. So now we are going to have the exercises, right? So let's go for it. Right. So let's write the questions.
Dayam Alkismu.
Yeah, Rizwan. I was in a call, and during the call I was writing these things. So that's why I was muted. So here it goes. Right now you can try these questions. So you only need to convert this into the binary. And there are both the hexadecimal and octal values. Okay, so yeah, you know the drill, right? Do this and send me the answers as a chat message. So I'll tell you how the things have grabbed by you, right? Yes, Udan, let me check. For the first one, yes. Yes, that's correct. Second one, I think you made a mistake, a small mistake. Just go through and see. Don't panic, people. These things are very easy. So because of that, do it slowly. No. Udan, again, there is a mistake. Go it slowly, go it slowly. Yes, now that's correct, Udan. Hit me, yes, the first answer. Yes, that is the answer. Numi, first one is correct. Second one is correct. Third one is also correct. Mihini, first one is correct. Kidney, second one is correct. Udan, third one is correct. Kidney, this is the third one, right? Yeah, that's correct. And Utkarsha, yeah, first one is correct, second one is correct, third one is correct, fourth is also correct, fifth is correct, sixth is correct. Very good. All correct, Dua. Very good, very good. Udan, yes, the fourth one. Yeah, that should be the fourth one. Yes, that is correct. Mihini, second one is correct. No. Yeah, Udan, let me see the sixth. Sixth one. Yes, that's correct. And the fifth one. Yes, that is also correct. Sanushi, first one is correct. Second one is correct. Third one. Yes, third one is correct. Fourth one is correct. Fifth one is correct, as well as the sixth. Very good. Yes, Mihini, the third one, yeah, that's correct. Dulandi, yes, first one is correct, second one is correct, third one is correct. Dulandi, the third one, I think there's a one mistake. I think it's a typing mistake. Just see whether you have typed it correctly. Newmi, yeah, the fourth one, there is a slight problem with the fourth one. Fifth one is correct, sixth one is correct, but not the fourth. Mihini, yeah, your fourth one is correct. Kitmi, yes, fourth one is correct. Right. So let me do these things quickly. So that will be easy for you to see whether you have got it correctly or not, right? So, yeah. Okay, so there you go. First one, 376. So 6 can be written as 1, 1, 0. 7 can be written as 1, 1, 1. 3 can be written as 0, 1, 1. So the final answer is going to be, we can ignore this 0. And final answer is going to be this. Second one, 452. So 2 can be written as 0, 1, 0. 5 can be written as 1, 0, 1. 4 can be written as 1, 0, 0. So this could be the final answer. Third one. Yeah, Kidney, yes, the answer for the fifth is also correct. Third one, 713 in octal. So 3 can be written as 0, 1, 1. 1 can be written as 0, 0, 1. 7 can be written as 1, 1, 1. So this is going to be your answer. Yes, last one is also correct with me. Right, in the fourth, those are hexadecimals. It's 127 in hexadecimal. So 7, we are going to write this in 4-bit values. So 0, 1, 1, 1 can be taken. 2, 0, 0, 1, 0 can be taken. 1, 0, 0, 1 can be taken. So all 3 zeros, which actually as the leading zeros, can be ignored. So the final answer is going to be 1, 0, 0, 1, 0, 0, triple ones. So that's going to be the answer. The fifth one, it is 3E5. So 5 can be written as 0, 1, 0, 1. E means 14. It represents 14. right? So 14 can be taken as 8 plus 4, 12 plus 2, 14. So we don't have 1 for that. 3 can be written as 0, 0, 1, 1. So the final answer, you can ignore these two. So it's 1, 1, 1, 1, 1, 0, 0, 1, 0, 1. Right. So the sixth, it is TF16. F stands for all ones because F means 15, D means 14. Not the 14, it's 13. I'm sorry. Right, so 13 can be written as 8 plus 4, it is 12. Not 2, just 1 for 1. So the final answer is going to be 110, 1111. Okay, people, is that clear?
Yes, sir.
Yes, sir.
Right, great. Okay, so let's move to your textbook for a moment and let's go through and see did we miss anything out of this. All right, and yeah. So yes, we started from here. We talked about different types of number systems. We talk about the most significant and the least significant values. And yeah. And the conversions. We did lots of conversions and we talk about 4 different conversions like decimal into non-decimals, non-decimals into decimals, and binary into octal and hexadecimal, and finally octal and hexadecimal into binary. Right, so that gives the conclusion for the number conversion, right? So now we are going to talk about the data storage capacities. Right, so here you are going to learn about bits and bytes given, right, which is a major component when it comes to the computing, right? So when it comes to the capacities in computer, they use the smallest unit as bit. Bit indicates, or like the extraction of the bit can be taken as binary digit. That is how the bit has been made out of. And bit is considered as the smallest one, right? And collection of 8 bits will be a 1 byte. And there is something called nibble, which indicates 4 bits together, right? We are not using nibbles these days because it is outdated now, but in early days, they use nibbles. Now it is bit byte. Then after we're talking about kilobytes, megabyte, gigabyte, and all these things, right? So I want you to have this picture with me, right? Not with me means like only thing that you need to understand how it is. And if I tell you the smallest unit, the bit, is represented by this small dot. And there will be 8 dots to represent a byte. And when this byte is trying to represent a kilobyte, which is the next one in the row, right? So when it comes to the story of the kilobyte is equal to the 1024 of bytes. Now you can see how many bits are there. And these type of boxes, 1024 of these type of boxes will create a kilobyte. So it will be huge, right? Kind of a huge one, which is going to have lots of dots inside this. Right now, if you think about a byte is a small tomato, bit is a small tomato, one particular tomato. Byte means it's a small pack of tomatoes, like maybe a lunchbox size of a box can represent a byte comparing to tomatoes. So like if it is a kilobyte, we should have 1024 boxes of those tomatoes to indicate kilobytes. And when you are going from kilobyte to megabyte, megabyte means thousands of kilobytes. And think about how big that the megabyte is going to be comparing to the kilobyte. 1024 times of kilobytes. And when it comes to the gigabytes, gigabyte means again 1024 megabytes will be equal to the gigabytes. Right, so it's kind of big and it's getting bigger. Right now, if we scale it onto this board, I'll take this as a bit. And if I put my 8 bits together, right, this kind of a small box is kind of a byte. And kilobyte, of course. Right. And the megabyte is kind of pretty big. Right. So this is kilobyte. This is megabyte. And if you think about the gigabyte, it is 1024 of this space. Huge one. Right. If you think about terabytes, it's 1024 of gigabytes. Huge one. Right. So likewise, it's going to grow and we are going to measure on like that. Right. And it's better you know this relation because in some of the papers, they have given some small calculations for you to calculate. Like they will generally ask like how many kilobytes are there inside 4 megabytes. Right. So in some cases, you have to do some different types of conversions. Sanushi 357 and 359. Let me check what you are asking for. Yeah, we Sanushi, we did 357 is converting octal into hexadecimal numbers. Okay, converting octal into hexadecimal values. Yeah, that's something that you have to do by thinking, having some thinking into it, right? Like it will be converted into the binary, and later that binary value will be converted into the hexadecimal, right? It's not something that we have to do like as a topic doer. When we are doing the questions, we will be getting into these things, right? Okay. So when it comes to this particular unit conversions, sometimes they will ask, we can use this type of a chart, right? This will make things easy for you, right? How the chart is, it's like this. Bit is the smallest one. So after bit, you will be finding the byte. After byte, you will be finding the kilobytes. After kilobyte, you will be finding the megabytes. After megabytes, there will be gigabytes, terabytes, terabytes to petabytes, right? That will be enough. So how the conversion happens? Is there? So to convert, I don't know. I think she just came. Right? To convert petabyte into terabyte, you need to multiply this by 1024, because 1 petabyte equals to 1024 terabytes. Converted by 1024 means multiplying it by 2 to the power 10. Because 1024 equals to 2 to the power 10. And terabytes to gigabyte, again, you have to multiply it by 2 to the power 10. It is because 1 terabyte has 1024 gigabytes. And from gigabytes to megabyte, again goes the same thing, 2 to the power 10 multiplication. Megabytes to kilobyte, 2 to the power 10 multiplication. Kilobytes to bytes, 2 to the power 10. And byte to bit, you have to convert, you have to multiply it by 8. That means you are multiplying by 2 to the power 3. Right? So you have to come step by step from a bigger unit to a smaller unit if they are asked to do so. People, is that clear?
Yes, sir.
Right. Then when we are doing the other way around, like if we are asked to convert bits into byte, we are going to divide by 8. Right? Divide by 8 means multiplying it by 1 over 8, which means multiply by 2 to the power minus 3. Right? Because 2 to the power minus 3 equals 1 over 2 to the power 3, which equals 1 over 8. Right? So multiplying by 1 over 8 means multiplying by 2 to the power minus 3. Right? So on the other cases, from here to here, here it's going to be 2 to the power minus 10. And from here to here, it's going to be 2 to the power minus 10 again. Oh, what happened? Oh, this happens always.
So it has disappeared. No, sir.
Yeah. It's bad. Okay. Draw it again. I'll draw it again.
Sir, can't you like redo the last thing that has been done? Isn't there like such option in this?
Rizwan, I'm not getting you, Rizwan. Okay. Yeah, no, Rizwan. Like, I think I'm mistakenly touching this erase all thing. Right. If I could take it to the upside, but I don't think. Yeah, not now. Never mind. I'll write it quickly. No, because it is like once it is done the erase all, it's kind of a permanent deletion. Never mind, I'll write it quickly. Should be on her way, Suzu.
But you think Tommy already come?
There is nothing for come, Suzu.
What?
Suhara.
What's from?
And from byte to kilobyte, it's 2 to the power minus 10. Now you can see the pattern. Here it is 2 to the power minus 3. So it happens in 2 to the power minus 10. Right, so we can call this, can have the heading saying unit conversions. Okay, so you can write this down, people. Then I'll show you how to do the conversions in a very easy manner. Right? First, write this down, everyone. Okay, one is done. How about others? Anyone who is still writing? All right, so yeah, so I'll show you how the conversions are going to happen. So I'm taking an example. Let's say you are asked a question, something like this. So example number 1. Right, find how many kilobytes are there in a 4 GB. So what you need to do is you need to convert 4 GB into some amount of KBs. Right? So how we are going to do this? First of all, you are going to write the journey from gigabyte to kilobyte. So it's going to be gigabyte, then it comes to the megabyte, then it will come to the kilobyte. Right? Udan, no, it's a little bit different, Udan. I'll show you, hold on. Right, so what are we going to do is we write from gigabytes. First, we have to come to the megabytes. From megabytes, we have to go to the kilobytes. That is the journey from gigabyte to kilobyte. Then what are we going to do is we are going to take this 4 as it is. We are not going to change it. And we put the multiplication sign, another multiplication sign. Then we consider how much we want from gigabyte to megabytes. So moving from gigabyte to megabyte will need you 2 to the power 10. That means you are going to multiply this by 2 to the power 10. Then we consider how much we want from megabyte to kilobyte. Again, megabyte to kilobyte, we need 2 to the power 10. That means you are going to multiply this by 2 to the power 10. So it will give you the value in kilobytes. So the final value can be written as 4 into, you know that when multiplication happens, these powers are going to add together. So it's going to be 2 to the power 20 kilobytes. Right? And 4 into 2 to the power 20 can be written in different ways, people. Why it is given the chance of writing 4 into 2 to the power 20 in different ways? Because 4 can also be represented as a 2 to the power. Right? So 4 can be represented as 2 to the power 2 into 2 to the power 20. So we can say it is 2 to the power 22 kilobytes. Right? Or else we can write it like 2 into 2 to the power 21 kilobytes. These are just alternative answers. You really don't need to write those alternative answers when you are doing a calculation. But in the MCQ paper, this 2 to the power 22 can be represented in many different ways. Right? Yes. And Udan, you don't need to multiply it and see how much, or like what's the value of 2 to the power 22, right? So don't worry about it. It's much better if you find, it's much better if you have it as a 2 to the power. That will be sufficient. Right? So you can have many different ways for the representation of 2 to the power 22 in kilobytes. So it's just a number game when you know the number. Is this clear, everyone?
Yes, sir.
Right. Okay. So let's write down. So the first example, after that, we'll convert a bigger value into a smaller one.
Excuse me, sir.
Yes, Dua.
Sir, I had an internet connection problem. Should we write this down?
Yes, yes, you must do it. It's the first exam.
Okay.
Okay, are we done?
Sir, I had a power cut a little bit earlier, so I joined through hotspot. Should we write it in
Yes,
this?
yes, Rison. You should write that.
Sure.
Write down quickly. Write down quickly. I will stay. Okay, anyone who is still writing this? Okay, so let's move forward. I'm doing the second example. Right, find how many megabytes are there in a 2 to the power 24 bytes. So our task is 2 to the power 24 bytes needs to be converted into megabytes. Right, so again, the same thing. We have to write the journey from bytes to kilobyte, from kilobytes to megabyte. So goes the same way. 2 to the power 24 will be taken as 2 to the power 24 as it is. And from bytes to kilobyte, how we are going to convert bytes to kilobyte? See, we use what? 2 to the power minus 10. Right? So that 2 to the power minus 10 should be written over here. So it is into 2 to the power minus 10. And from kilobyte to megabyte, again you need a 2 to the power minus 10, which gives you the value in megabytes. So this means what? 2 to the power 24 into 2 to the power minus 20 megabytes. That means when multiplying plus 24 reduce a 20. So that means 2 to the power 4 MB, which means 16 MB. Is that clear? Yes, everyone. Is that clear? Right, great. So write it down.
Clear, sir.
Right, okay. So write it down.
Yes.
Then we'll practice some questions on the next day, as well as we will be able to finish up the lesson by next day. So you can write this down and then you can leave the session since the time is up. Right, so thank you very much, everyone. I will be here until you are done with this. So you can write it down, then you can exit.
Sir, the answer.
Right, okay, Dua. If you are done, you can exit. Thank you very much.
Thank you, sir.
Thank you, sir.